Thanks, Diane, and welcome everyone this afternoon. And this session this afternoon has been a few years in coming, and I think what really brought it to focus this year was our energy costs. Like, I think for me, I didn't get the memo that I should have locked in my energy rates for electrical, and I'm now paying 3 times as much as I was 6 months ago. So disappointing. But for other people, we have things like solar projects that used to take 25 years to maybe pay off, and now with electrical costs the way they are, and levels of funding from some of these programs that are supporting our sustainability and competitiveness as farms, the story has changed. So we're in a new world here where there's money available and costs are high. So this is the time to strike on some of the changes we can make. So I just briefly want to introduce our 3 farmers that we have collaborating with us on this talk today. So first, we have Trent Sungard from Sungard Poultry, and he's going to be talking about a solar project that they've been working on in the past few years, and it's continuing to expand. He was telling me, I thought he was second generation because I know his dad, but he's actually a 4th generation in 80 years to grow feathers. I think that's just fantastic when we look at sustainability of the industry. He's also a 2nd generation dirt farmer near Standard, Alberta. And one of the things he said about himself is that he likes DIY among some other things, but I just wanted to focus on that one because I think that's like the #1 criteria to be a farmer. You like your DIY because there's going to be a lot of that. And so, and then next we have Jerome Veltais. He's the owner operator at Veltais Farms, and he's northeast of Edmonton a little bit, and they have about 85,000 broilers. And they started broiler farming in around 2008 when him and his parents, they left the dairy farm and switched to the light side from the dark side into poultry production. And so he'll talk about the changes they've made when it comes to things like their heating systems over that time, and then what happened in their most recent project with heat exchangers. So, and then he's also, they're growing for the future, so they also need sustainability in the industry because they've got a big family, and so there's there's likely to be some succession planning there too. And finally, we have Jason Bourne. He is been a big part of Alberta chicken producers as a board member for us in the last 9 years, and most recently our board chair for the last 3 or 4 years. And he is the owner operator of Tri-West Poultry. And I'm trying to remember his story of how he started on this. I think the farm was in his wife's family, and then when they got married, they got put into their hands to find a way to manage. And so he does manage it from afar, along with some other business ventures, but he spends a lot of time in Alberta still on that farm. And he's a numbers guy, and he's wonderful to talk to when you look at looking at the pros and cons and charting progress and so on. So, and he'll be talking about their change over to high efficiency heating systems. And so, I'll leave it to them to take over. So you'll see what we came up with.
Good afternoon, everyone. Hope everybody is having a good day. Renewable energy is being adopted to a large degree in Alberta every year. Alberta is currently at 8% production of energy from renewable sources, and the Alberta government has legislated target of 30% by 2030. I don't have current numbers, but did you know that according to NRC Natural Resource Canada in 2014, close to 60% of Canada's energy production was from renewables, mostly from hydroelectricity in Manitoba East. This discussion is a pretty big wheel. It's full of politics on carbon footprint, the effects of wildlife, the inherent impact of global warming, the environmental impact relative to traditional energy sources, digression of needed concrete and environmental effects of its production, 93,000 orphan wells in Alberta alone. Do electric vehicles have a role? Hydrogen, ammonia production, displacing farmland for huge solar farms, cryptocurrency operations near large points of cheap energy sources and its effect on domestic markets. Solar flares in our electrical grid, the reclamation of generation equipment at the end of life for all the energy sectors. But let's save that for a talk over a beer. This is a big conversation, one that impacts especially intensive livestock producers like myself and many in the audience. It's full of politics, opinions, and subject to perspective and personal needs. So this afternoon, I want to focus on my experience and hopefully keep politics and ideologies out of the conversation and maybe convince you that payback for solar isn't 15 to 20 years. In fact, it can be a passive income in less than 10 years with the right partners. On our family farm, we've been an active producer of solar energy for over 10 years. Next slide, please. It started out with moving an existing broiler barn from Calgary to our grain farm. And in the reconstruction of this chicken house, we incorporated solar by using it to condition the makeup air for over 30,000 broilers. We did this using a product called Solar Wall from a now defunct company called Solag in Quebec. But I think the product is still available from a company called Conserval in Ontario, or perhaps Quebec as well. For lack of a better description, it's 3,200 square feet of vent and soffit, painted black. It has high thermal mass. It has a higher thermal mass than soffit as it's steel construction, not aluminum. But it's nearly identical in its construction. Ribbed with perforations to draw in air, it passively produces heat, especially during the winter. I've had infrared thermography done on the wall in November after a few years of its installation, and it measured over 50 degrees centigrade at the top of the wall. That's pretty impressive. It also buffets the inlets from the wind and helps scavenge heat loss from the building envelope, as it contains heat loss and draws the incoming air through its lost energy. Next slide, please. Our experience in producing solar electricity began in 2013 with a small solar photovoltaic pilot project through Growing Forward. This was a small 9.8 kilowatt system, and it got our feet wet and put the map dot on our one farm into the classification of micro generation. Next slide, please. What this means is that we have an agreement with our wire service provider, who happens to be Fortis in my area. And this is a very important step and cannot be diminished, as it sets the framework of business. It outlines the technical and legal aspects relating to the intent to participate in the electrical market as a producer. When I signed the agreement, I acknowledged that I was eligible to represent the farm. We agreed on the technology that would be used to provide the connection to their infrastructure. I agreed to maintain my system on a regular and described fashion from the manufacturer. I agreed that there would be an automatic disconnection switch installed so there would not be any exporting of excess power during the power outage. And this is also important because of my backup generator is not compatible with solar production, as the electricity produced is not synchronous to each piece of equipment. And when the sine waves produced from the generator and the solar inverters meet, it's likely to cause severe damage to each piece of equipment. I also agreed on that agreement from Fortis that they can come and disconnect my system if it becomes dangerous to operate. And thus I agreed to provide access to my equipment for them to inspect, and I also agreed to liability, termination, and transfer of ownership of that agreement. Next slide, please. Part of the agreement application was the submission of a single line diagram showing the wire service provider the equipment that would be installed. Here's one of my single line diagrams that are a fixture of the equipment installed and accessible for the inspection by any party. I've used two different companies for my three projects, Skyfire Energy out of Calgary and Westcan Power out of Calgary as well. Both have provided exceptional service with zero issues for a turnkey installation. Next slide, please. What I mean by turnkey installation is that they look after everything from my building structural inspection and engineering approvals, development permit information and electrical permits, working with the wire service provider and submitting any needed applications. They commission my system and made sure Fortis installed a bidirectional meter, which is necessary to measure and compensate the farm financially for excess electricity generated and exported. Next slide, please. We started off as microgenerators using a retailer that was unfair to us, and because we have a deregulated market in Alberta, when we upgraded the system to 65 kilowatts in September 2016, we abandoned them for our existing retailer who has made the economics of participating in the renewable energy market simple, easy to understand, and quite competitive. My existing retailer allows us to jump in and out of a microgeneration niche market where producers like our farm are paid a premium for electricity exported. Historically, we have participated in the program for the months of March through October. In September 21, we completed 2 additional installations that included the introduction of solar photovoltaic to our other farm and opened the door to microgeneration opportunities at that location. Next slide, please. I feel that the key to being successful as a solar photovoltaic microgenerator in Alberta is to understand the market and especially the billing system. Although we have a bidirectional meter installed, we don't have net metering market. We have a net billing market in Alberta. We pay for demand, we pay for transmission, distribution, and trading costs, and somehow, I've yet to have it properly explained to me, we also pay for the carbon tax in the electricity we use. Having a retailer that understands how to participate in the renewable energy market will lead you to success as well. Next slide, please. It's essential that you build initially as big as possible with panels that are as big as possible as well. I say this because of the labor component and the significant cost they represent in the installation of the solar system. The labor is about, from my experience, 40 to 60% of the cost of the project. It takes the same amount of labor to install a solar inverter, a small solar inverter, as it does a large inverter, and the cost of the inverter is typically lower on a kilowatt basis, so the benefit is captured twice. Same with the panels. The racking system and the installation of the panels also take the same amount of labor for large panels as it takes for small ones. Also, the installation of a 3-phase system, for those that have 3-phase power, is slightly less expensive and thus changes the economics slightly when you compare it to a single-phase system. And it's cheaper because of the way the equipment interfaces. Before deciding on a system size, discuss with your wire service provider, Fortis or ATCO, or maybe you have a local co-op that provides electricity to you, your equipment upgrades that could change your efficiency and the long-term success and options, such as increasing your transformer size. This likely come at a cost to you, but in the big picture could be quite beneficial. Next slide, please. I personally choose to select products manufactured in North America. Most of the products in the market come with a very strong warranty, 25 to 40 years, possibly longer than the life of the roof that they couldn't be installed on. It is true that solar panels will degrade over time, but the degradation is less than 0.25% per year, and our wire service fees inflate much more than that over time. Next slide, please. If you're interested in venturing down this potential source of passive income for your farm, I suggest talking to producers that have done this already to help eliminate any frustration and ease the comfort knowing the project will be executed properly. I'm aware of a few other feather producers that have solar as part of their operations as well, so we're not that unique. Have open conversations with installers and perhaps request the 25-year cost benefit analysis projecting revenue and cash flow. This could be a filter for the capacity of the company you choose. If somebody can do that, they're perhaps up for review, and if they fail to understand what you're looking for, that's an easy decision. The installation of solar panels on the roof of the chicken house also lowers the ambient temperature of the roof because of the air gap between the roof and the panels. This airspace helps insulate the roof from high temperatures, a bonus for keeping our barns a few degrees cooler during the summer. Some installations employ ground mount systems and tracking mechanisms as well. I do know the costs and the engineerings are different from region to region based on building code, structural capacity, so it's worthwhile to investigate all of your options before spending money on solar PV, and perhaps determining if it's beneficial to put your panels on a roof or on the ground. There is also an opportunity for accelerated depreciation for renewable equipment when you file your income taxes. I believe it's 50% depreciation for renewable equipment, not quite as good as the new 100% depreciation we have access to for new equipment. And I don't know if solar would qualify for the 100% deduction. Regardless, my point is there's some tax benefits to be considered in this offsetting decision. Next slide, please. In addition to solar photovoltaic, on our farm, we also use the sun to heat a few small buildings. I have a watershed that relies solely on 2 arrays, a small workshop with 1 array, and a machine shed that is heated using 6 panels. Next slide, please. Last week during the cold snap we had, it was minus 25 degrees and the sky was clear and sunny, an enjoyable February winter day if there ever was one. And the sun heated the water glycol mix to almost 35 centigrade at several gallons per minute. No transmission fees, distribution costs, no carbon tax. The sun heated the water and powered the pump. Next slide, please. To wrap up this conversation, I encourage those interested to take advantage of the environment we're in, both the climate, the economics, and the politics of today. Do your research deliberately, cautiously, and make sure your investment is right for your farm, and it's not just a feel-good moment. It has to make financial sense like any other investment on your operation. Next slide, please. Current costs per watt for solar panels are about 60 cents per watt, but you still need an inverter, cabling to connect, skills, knowledge, racking equipment, etc. And that brings current pricing from systems under 20 kilowatts to around $2 per watt. And larger systems, of course, will be less expensive, possibly less than $1.80 per watt. But inflation keeps eating at those numbers, and there was recently a 15% increase in the cost of solar panels and its associated equipment such as inverters. Solar electricity can be measured. The market has demonstrated it wants it. And as producers, we are positioned somewhat uniquely to participate. Last slide, please. We have luck. I had a slide with questions.
So Jerome, thanks for having us here today. I know one of the things we're trying to do this year is have a closer look at some of the technologies that farms are using, especially when it comes to improving efficiency. What's the history of this site?
Okay, yeah. In 2007, we had a dairy farm that we sold, and we came across this boiler farm, and we ended up purchasing it in 2008. It had 2 barns. I was leasing out quite a bit of quota, so by then I could fill the whole barn with the quota that I was leasing out, and to grow the birds myself.
And this barn is around the same size as the other 2.
The other 2 barns are around that 17,000 square foot each, and this barn is 17.5.
Yeah.
So
the original barns, you upgraded the heating system in there.
I was heating with coal, using a fin tube system on one side of the barn. It was breaking down a lot, so then I upgraded to gas efficiency boilers. The main reason why I changed was just because the coal furnace was breaking down so much. I just did not want to work with it anymore. Then they were also starting to introduce this carbon tax for coal. So then your gains of using coal are not there anymore.
So then for comparison, so that was high efficiency boilers in those barns. Now in the new barn, what did you do for a heating system?
Yeah, the radiant heaters. I put in 12 of those.
Yeah. It feels really good here. He turned them on for me because I was kind of cold today when I got here.
Fin tubing is pretty expensive to put in, and I would have to put a couple of loops or a loop on each side. They're a little bit harder to clean, the fin tubes as well. I do have 3 forced air heaters in the old barns as well, just as a backup. Just when it gets really cold, then my fin tubes can't keep up.
Yeah, so that's your setup. So do the other barns also have tunnel ventilation and
No,
blackout lighting, blackout vents and all of that?
no, they do not. They just have the side ventilation.
Okay.
So air inlets on one side, fans on the other side.
Yeah.
And that's all they have. This barn has tunnel ventilation, that's right.
Yeah. So when you first were deciding to put these in, like how did you come upon these?
Yeah, so I was ready to pretty much build this barn. I had almost the contract signed, had the permits ready. And then the gas company came back to me and said, well, we don't know if we can, or we don't think we can supply enough gas for you to build this barn. I was talking to the equipment company that I got all the equipment from, and they came with this idea of these heat exchangers. It's supposed to reduce your gas by 40–50% usage. So yeah, that's why I put them in. For the first year, when the gas company did not have their upgrade done yet, staggered my placing of this barn, like I did 2 weeks later than the other 2 barns, to reduce peak demand.
Then in terms of like cleaning, like it's going to pick up some dust on top and so on, but
It does, yes.
it doesn't get really fouled up? Like,
On the outside it doesn't, yeah. Like you said, there's some dust on top. When we bring this unit down, you can wash it good. And in the summertime, all you do is really blow them out and they are clean again. But in the wintertime, with the high humidity and the moisture, it just builds up and it's just muck. And then when you have to take that down.
yeah, so when it came to cleaning on this one, like one of the things you said is that it's a little awkward for...
It is really hard to do it one person, because you have to have one person that kind of lifts it up. No, either my dad or my wife will help me take them down.
Okay, so
yeah.
it's not like you need someone super strong.
No,
Yeah, so-
no. You just need that extra little
yes.
hand. Ideally, you want the water lines a little closer to the wall, but I had to move them out a little further so that I could bring these units down to wash them.
So do they have to be at that height, or is that just based on like where your eave is?
Yeah, well, I would like to have them as high as I could, because then I can still drive underneath them with skid steer and zoom them.
Yeah. Okay,
So
there's
that's why we put them at that height. But yeah, if you have lower barns, then then they might just have to sit lower. Right? So.
So in terms of like, I know people would be interested to know like the difference in profitability with changing things for efficiency. So it's a little tricky to compare the site because you have your 2 old barns that you retrofit with high efficiency boilers, and then you have this barn with a slightly different heating system, 100 grams of extra.
Yeah, so I do get 100 grams more per bird, growing them in the same amount of days in this barn.
The difference in raw profitability between these two is like how much per square foot or
Yeah,
per
I would
bird
say, with also the reduced mortality, it would be about 35 cents per square foot per cycle.
So this barn makes how much more in a cycle then?
Yeah, I mean, it would if you're doing 100 grams per bird more, it would be about, in less mortality, about $5,000 you make more in this barn.
Yeah.
Right, so.
So then, if you take the actual cost of the units and just, if we were to say that's 100% to do to them, you could have this paid off in less than 2 years.
Yeah, in less than 2 years. Yeah.
But now realistically, from like, what are your thoughts on really the payoff time?
I'm thinking more like 5 to 7 years, with the increased growth, lower mortality, a little bit of reduced gas costs.
Yeah.
Yeah, I would say. Yeah, I'm really happy with what I'm seeing in the barns when it comes to the birds. Walking through how they look, nicely spread out.
Yeah.
And also just their activity. They seem healthy. Yeah.
So do you see differences in the way birds behave in this barn compared to the other 2?
I do, yeah.
So
yeah,
what
they're
is
more
that
active
like?
in this barn.
More active, okay.
Yeah, and I think it might have to do with the lights, though.
Right. So yeah, so I guess in terms of bird health, that you had said that this barn did perform differently than the old ones?
Yes. Overall, my humidity levels are down the first 2-3 weeks. CO2 levels are lower as well compared to the other barns. And then overall, over the last year, when I look back, my mortality has been better in this barn, about 1% better.
So how high does the humidity actually get in those first 2 weeks?
40, 50?
Not getting out of control.
No, and the other barns are like when it's really cold in the early weeks, by week 2, it's probably close to 60.
So now you got your other barns, and I know they have lower ceilings, so they might not be, is that right? They're not, maybe, the heat exchanger might not fit as well there?
So I would, like, if I would put something like this in again, it would be more like something like with a flush mount on
Right.
the wall so that they don't come into the barn. Then I would put them in.
So, and this company does have that.
Yeah,
they didn't when you built this.
No, they did not. I would consider it because I really like that I don't use any exhaust vents for the first 2 weeks, especially when it's cold.
Right.
I just use these heat exchangers, and
Right.
I think that really helps the birds out to not have that cold air coming in off the inlets.
And that's cycling, so you don't
Yes.
have the fan turning off and on. It's
That's
just
right.
the same all the time.
Yeah, these ones, I start at a low percentage, like I start at about 35% capacity, and they recommend for the first week to only use 4. So when it's really cold, I will only use 4 of them, and then by week 2, they recommend to start using all 8 of them.
Right.
But in the summertime, I'll start with 8.
So these essentially then act as your recirculation fans in those first weeks?
Yeah, they do that as well. Yeah.
So if you were to build a new barn tomorrow, is there anything you would change compared to what you did in this project?
The only thing I would really look into is getting more of a flush mount heat exchanger.
Okay.
Other than that, I'm pretty happy with this barn.
So Jerome, thanks for having us here today. I know one of the things we're trying to do this year is have a closer look at some of the technologies that farms are using.
Right, good afternoon, Jason, and thank you for being with us today to talk about your project. I know I was at your farm to certify that facility a few years ago. At the time, you were talking about putting in an efficient water heating system for the barns, and in conversations after, you talked about how the increased savings you were seeing early in the project caused you to make changes in other buildings as well.
Right. So in 2011, we built 2 barns. 2013, we built a third with the hot water system, the sort of the main loop running through the barn, flexible hose down to a radiator with a fan on top. Essentially, they were custom manufactured by a colony. We put that in our first 3 barns and really liked the efficiencies of that system. It was there was growing forward funding available at the time, which we took advantage of to reduce the cost of the equipment. There was no funding for the overall project. And so what I decided was that we would put it into our older facilities, knowing that there probably would be some improvement. We didn't really know what at that time when we made that decision. We said, well, okay, we like the system. We were going to build a 4th barn right beside the old one. So we were going to install this system anyways there. And so we figured, let's just build one central mechanical room then. And so we just had to deal with one header from there, pipe it into both the old barns, but also the planned new facility, which was going to have the same heating system as the other 3 barns that we did. So, but once we did that, we noticed a market improvement in gigajoule per kilogram, which is what I was tracking. Under my older barns previously to the change, we were using roughly 15% less gigajoules per kilogram, 15 to 20. It just depends on, there's a lot of variables, weather and number of kgs and all those different things, but it was between 15 and 20% reduction in gigajoules per kilogram once we installed the new system into those facilities. I averaged my gigajoule per kilogram for the 4 years prior to the project, because you got your multiple cycles you got 6 and 7. So you got to I do a 2-year average, and then I did it over 4 years. So I had two-year averages. So I had 4 years of data and calculated my gigajoule per kilogram shipped. And then I also did it then for the 4 years subsequent to the change, and on the same basis. And that's where I came up with the numbers. When we did this project was 2017. So I did it for the years prior to that and then post that, but I haven't updated those numbers since my initial calculations. So that was about a 13 to 15 year payback, depending on your metrics. And obviously with gas being more expensive now, if you do the project now, it's going to have a better payback. At the time we did it, gas was, I don't know, $2 a gigajoule plus your transportation. I think I figured all in my gas cost at the time was about $5 a gigajoule. And now you're looking at minimum $8 with the carbon tax tacked on and all those other things that have added to the cost.
So Jason, with that change, have you seen any difference at all in the mortality or 7-day mortality or flock health status?
I would not say a substantial improvement in our production numbers. I haven't even seen necessarily a trend that's significant enough to say this is sort of the cutoff date and that's the change because of the change in heating systems. I think there's just too many variables at play. Conditions are quite superior in a hot water heated barn. Some producers might argue with me on that. From a management perspective, my team on the farm has always said to me that facilities are much easier to manage. Litter stays much drier. Our catching operations are much easier in those barns. We still have one old barn with the old heating system in it. The reason we didn't change that one was it was too far away from the other 2 older barns to actually run the heating pipe underground to it, and it was too cost prohibitive at that point. We can compare the conditions in those barns, well, pretty much every cycle.
So when if you go back to when you first decided on this changed heating system, how did you learn about this heating system, and then what was that process of who did you kind of consult with?
We toured quite a number of facilities the year and a half prior to us going ahead with our project. We had seen this system in use in a number of facilities in the province. There were different models at play that were being done at the time. Some were using just regular mid-efficient boilers. Some were using high-efficient boilers. It's a fairly flexible system. Yeah, so we just did a lot of touring and talking to people and then talking to our equipment suppliers. And you got to work with your mechanical contractor quite closely. Like, you have to know how much BTU you're going to need in your barn for the size of your facility, and of course that translates to how much heating horsepower you need on the front end with the boiler system. So there's a lot of conversations that have to happen. We went with a system that was high efficient. The reason for that was because we wanted to access the funding, and so we did. At that time, it was 70% of the equipment cost was covered by the Growing Forward program. If you look at the current PFIP program, the Poultry Energy Efficiency Program, that's available to producers at 70% of your project cost, which I think would be a substantial opportunity. If you can actually cover additional costs in addition to equipment, that payback would become even that much lower.
And so now, if you were to build another barn, what would you do next?
Actually, that conversation's occurring right now. I do have an NRCB approval to demolish the old facility that's quite a ways away from our other barns, and build a new one on it. So I am exploring that right now in terms of could we tap it. So we do have enough boiler BTU at our central mechanical room to run a pipe underground to that barn. It'd be a bit of a minefield, going to start digging through our yard again and so forth. So one of the things we're talking about is possibly directional drilling it but it's a bit of a challenge because it's a fairly large pipe and there's a lot of questions about how can that happen, and it has to be insulated or foamed around it. So when we did the other 2 barns, we actually did cross the driveway. We brought the pipe up out of the mechanical room and then down and underneath the driveway. So we dug it down about 8 feet and then put an insulated pipe. It had the actual boiler hose boiler pipe in it, but then it had a styrofoam around it. We foamed the entire trench for frost purposes, of course. And so then we covered it up, and it's worked really well. But that was only about 25, 30 feet. We're talking about moving this thing 100 feet, perhaps more, 150 feet. So that's a fairly long stretch. So there is some question as to whether or not that'll work. You know, I would consider this system, even if I was going to do a standalone barn, I would probably install it anyways. It is a bit more money. It will be, if there is access to funding available, that would certainly help. I mean, and it's more complicated. There's more maintenance. I'm not gonna sugarcoat that. Maintaining boilers, maintaining water quality, maintaining pumps, hoses. There's just a lot of pieces and maintenance that happen that you have to be ready for. And you really, by rights, you should include that in your payback calculations. You know, if you're talking about a capital project, you know, my project was 13 to 15 years on the capital, but if I factor in the ongoing maintenance every year of that certainly impacts the payback as well. This sounds all really good, but there is a lot of maintenance involved in this stuff. That's with box heaters, you just kind of maintain the igniter every so often and a little bit of gas, and it's not a big maintenance item. Whereas with this system, it requires to stay on top of it. You have to have a mechanical contractor that you trust and that can come out and work with your facilities. You have to have pumps on hand. Like we have an inventory of pumps that we have on farm just in case one goes down. These days with the supply chain issues, if a pump goes down in your heating system and you don't have one in stock, well, you're totally hooped. So either you put backup heaters in your barn or you have standby equipment on farm so you can fix it within a reasonable amount of time. We have one of every pump that we have on farm. We can replace it within a matter of an hour if we have to. You make trade-offs as a producer. You decide, simplicity versus complexity and results and performance. So you have all these different variables you're playing with. So if you're a producer that wishes to keep the farm as simple as possible, this isn't the system that I would pick for that. If you're interested, so it depends where your priorities are as a business person, as a producer, and you make those trade-offs all the time in business. And so, there's no one right way to do it, but it just depends on your priorities.
What I'm hearing here is, like, if people were considering a change like this, especially with this opportunity with PFIP, there's definitely efficiencies in multiple barn numbers where, as a standalone barn, there's still a good payoff in a relatively reasonable amount of time, and probably accelerated now with current gas prices. But if you can build a central boiler system that you can get to multiple barns, you're really going to start to see some efficiencies in terms of the cost of your project.
You have to go into it eyes wide open. The bonus is the conditions, the management of the conditions, especially with the way we're proceeding with reduced use of antibiotics and so forth. Everything is so sensitive, right? You're on a bit of a knife's edge when you're managing the birds, and with reduced tools available to us to manage that on the antimicrobial side. Conditions in the barn are, it is really important, and any one little piece can kind of flip you off that knife's edge sometimes, right? So to us, that's just the bonus out of all this, is that, we get an economic benefit, but we also have a benefit in terms of our production.
There's a few kind of take-home messages here. One being, okay, based on the pricing at the time of gas and delivery costs, a 13 to 15 year payoff, that could be on paper 60% faster now just based on gas costs. But we also have to factor in everything's more expensive now. The program where we can get our 70% investment from PFIP actually also covers more than just equipment, so that can accelerate things. And the importance of having a mechanical contractor in your system. And then the final one there, that great point about having equipment on hand. If the pump goes, you need to be able to replace it. This is a lot. I just wanted to thank you today for talking about your specific project, allowing us to kind of listen and contemplate how this might work for our own operation. Thank you for being with us today.
All right, that's great. Rob, do we want to see if there's any questions for any of our producers? I think everybody's on hand live. I see Trent is even in his barn. Those were real sound effects, not like the Masters where they pipe in bird sounds. That was the real deal. So if you have any questions, we got a couple minutes left. If anybody has anything they want to ask any of our producers. Did you learn from each other? Anything you want to change from each other even? There's the birds, Trent. Oh, look at, there they are.
What side of the camera I was on?
There we go. Rob, did you have any more questions for any of our panelists here?
So yeah, I guess just to, are there any final thoughts after, because it's been a number of days since we last talked about some of these projects. Are there, and then based on what we saw today, are there any new insights into where people might go with this? I think you all did a very good job, first of all, of describing your projects. I had seen Trent's slides before, but I hadn't heard what he had to say. He may have been a little cut off right at the end, so I don't know if he had final parting thoughts for us there. But yeah, it's I think for me, one of the important things is the whole thing of going in with your eyes wide open, like where we really learn from each other as fellow producers and as industry partners is, you know, there's sometimes unintended consequences with these projects. I think of a producer I met with a while back who had tapped into one of the growing forward programs and put in an upgraded heating system. And because of the local supplies that were available, he didn't have like a good fin tube that was durable, and the rust that was coming out of there, and then like boilers that kept breaking down because they just weren't a brand that really worked for him. And because he was so far away from the supplier, the travel costs he was paying for the repair guy to come out over and over, he lost all his efficiency. So there's good stories and bad stories, and I mean, we hear a bit of the good news stuff here. And one thing that I would say is to help us keep learning from each other, if you are contemplating projects, definitely look at some of your before costs so we can compare the before and after, so you can see for yourself where the change is. Because we always question, we get told, well, this is the efficiency we're going to gain. Now, is the proof actually in the pudding? And if not, why not? So these are the questions we have to ask, because yeah, some of us are, you know, we sometimes get overly suspicious of claims until you can see it for yourself. So it's it sometimes makes us too wary to take that first step.
All right, we do have a couple of questions that have come in. First of all, Jason, do you have to blow out those heaters with birds in the barn?
Can you hear me?
Yes.
Okay, great. So good question. The odd time we do it, normally we'll be able to make it through a cycle without having to do that. Blowing the dust out, as all producers will know, is just something you would want to avoid doing if at all possible, just for respiratory challenges for the birds and stuff. So we avoid that as much as possible, but there are occasionally times where we will have to blow out the radiator in advance of the cycle being shipped or the flock being shipped. So we avoid it, but we do have to do it sometimes, yes.
Okay, and I'm guessing this is maybe your direction too. What kind of heating pumps are you using?
Okay, so our mechanical system, so I'm assuming, are you meaning the, just to clarify, the pumps for the boiler system, like the loop? Or what are they meaning by that?
I'm not sure. Just says what kind of heating pumps are you using? So
okay, our boiler is called Weil McLean. It's called Weil McLean. That's the manufacturer of the boilers, and the pumps that we use are Grundfos for the main pumps, and some of the smaller ones are called Taco or Taco. I can't remember how they pronounce that, but it's just the same as it sounds. So those are the two pumps that we use for the boiler system.
Okay, and we do also have a question here. With each of these systems, there are some large learning curves. How did you get the info you needed to make these systems work? Maybe, let's see, Trent, can we start with you on that? How, especially because you're venturing into kind of a new area with solar. How did you get the info you needed to make the system work?
I've always had an interest in solar. Am I live here?
Yes, you're good. Yeah.
Yeah, I've always had interest in solar. And it was really key when I made the connection initially with the company Skyfire Solar, and some of the principles there expressed great interest in my project and shared the interest in some of the passion in the solar, and were extremely helpful. And they participate not just as principals in their company, but they're advocates for renewable energy, and they sit on other boards that promote sustainability, and they wear multiple hats, and just super intelligent, willing to share, and willing to talk and tell a story. So we all have something in common. We're passionate about agriculture or energy efficiency and on and on and on. And we just engaged and communicated and shared stories and talked about perspectives. Skyfire really opened up my eyes to the economics of what solar is versus the stigma of the current conversation of what it's not. And I think there's a lot of people that are perhaps misinformed to the current possibilities. Sorry, I got a call here. I got a decline on. It's just a matter of communicating and having a perspective of what can I do versus, gee, I can't do that because it's not going to work. Well, figure out a way to make it work.
Spoken like a true do-it-yourselfer, that's for sure. All right, Jerome, what about you? With your heat exchange system, how did you get the information you needed?
The manufacturer of the heat exchangers, ESA, has been really helpful for me. Just setting them up on the Maximus and to control them. So they've been really helpful with that. Yeah, and then through some trial and error for myself, trying to figure them out. So, but no, they've been good. So
experience is a good teacher. Jason, did you do a lot of research before you went into the hot water system, or?
A little bit, yeah. Like Rob mentioned, or like was in our video there, we did tour a number of facilities just to check out different ways of doing this, and so that was the main method of research. There are a lot of learnings around boiler settings and sort of that managing your water quality. Those are things that you have to learn when you get into hydronics and that sort of thing. So that was a bit of a learning curve for us too, but that was just a matter of doing it. So, and a good consultant, mechanical contractor.
Yeah, those are key people for sure. Okay, other than the economic payoffs, is there a single other barrier to energy efficiency upgrades for poultry producers? What would you see as some of the barriers? Maybe Rob, I'm going to toss this one your way. You work with all kinds of producers. What do you see as some of the barriers before people would try something different?
So one of the barriers that comes to mind, especially in a year like this one, where things are a little financially tight, is that wariness about investment. I mean, in the different sectors I work with, there's sometimes there's something that is just a little bit too daunting, but if you actually took that step and realized how fast that might pay off for you, and in the long term, with inflation the way it is, or where energy costs are kind of casting up, just managing past that financial fear. And the other one is a lack of understanding, like that project I mentioned where the funds were there, so they jumped on it and signed some contracts too quickly in hindsight, and then they ended up getting a product that didn't work well for them. And so this is where that peer-to-peer learning is gold. And so if you are looking at systems like this, Jerome, part of the conversation we had that didn't show up there was, I think at the end of the first season, he was wanting to throw them away because those things were, as the condensation was running down the barn and then creating these giant icicles to the ground and then like causing big trouble. And then he had to actually change the shape of the outside of the barn to create slots there, like stuff like that. And I never knew until, like, I know there's other heat exchangers out there, and we do want to look at some of those in the future too, to kind of tell people about, but winter frustrations. And so for me, having him describe how their defrost cycle works, they actually don't freeze up. Like I learned so much from meeting you guys and talking about this stuff. So can't underestimate that peer-to-peer learning, and we can definitely help at the office connect you, because the more I know about the farms out there, the more I can connect you guys.
And is it somewhat timing too? Jerome, maybe we'll start with you. Is it a little bit about timing? If you've got an old barn like Jason is, and then have the opportunity to think about new, but if you've got a set barn, is that a barrier that maybe be there before, switching over to trying something new?
Yeah, I mean, it's always a gamble, right? And then also for me, it would be more like finding out more information about these different things you can do for in your barn for energy. I mean, it's hard to find information, I find, and that's a big barrier, I think. I mean, for me, I was kind of forced into the situation of looking into something like heat exchangers. So yeah, I was forced into it, but if I wouldn't have had this this issue with the gas, I don't think I would have put them in, because I wasn't even thinking about them. So just knowing that information is out there, I guess, yeah, we just don't know enough, I think. It's not readily available, I find. So, and that's a big barrier for me, I think.
It's something we're trying to reduce by you guys sharing your story here today, for sure. Anything you want to add on that, Trent, at all? I'm guessing you're the kind that are always poking around looking for new ideas, are you?
Yeah, for sure. I think I remember when I was young and my dad was farming, there was a lot more government support available. There was extensions through agriculture, and we had Rod Chernus was our local advocate for and source of information. If he didn't know the answer, he knew where to find it, and he had a great network. And that has kind of transitioned into from a provincial level into a board level. Now, if we need to know something or don't know where to look, we can pick up the phone and talk to Rob or somebody else at the office at ACP. I think as that access of information evolves and social networking, we're able to engage each other and communicate differently, and not necessarily better all the time, but it's different. We can, again, it goes back to sharing stories and communicating, and part of it is being open and honest with, hey, I tried this and it didn't work. It was a big mess, and perhaps that was some of the story with the HRV, heat recovery ventilators. I'm interested in that. I don't know how it works when it's minus 30, minus 38, minus 45. We've had that in the last 2 years, some extreme cold weather. And I know it's not ideal, but as we employ these different technologies, farmers were incredibly intelligent and able to solve problems. And I believe industry will solve that problem through encountering problems and difficulties. We'll figure out a way to make it work.
You bet. Okay. Well, I know we could go on sharing information like this all day, but I'm getting the big wrap up sign. So just one little quick note to pass along. Someone has passed along the information that one note on the water radiator, if it's aluminum and not steel pipes like traditional types and possibly placed vertical, that can greatly reduce clogging. So I'm not sure if that's a helpful tip or not, but thank you for passing that along.